In this video, we're going to look at how to start your Chapter 9 lab. And in the Chapter 9 lab, we're going on a treasure hunt. But it's kind of a drawn-out treasure hunt, right? So you can get directions that lead you on a little bit of a wild goose chase, and you're going to figure out where the treasure is. And then when you go back to Rackham, you're going to say, all right, this is where you should have just told me to go. Like, instead of having me go all over the coordinate plane, you could have just said, turn this, turn to this angle and walk this far, instead of doing all of this silly stuff in here. To turn in this lab, it's probably going to be either easiest to draw it and take a picture of it and put it in somewhere. You could use paint. Paint will probably be pretty easy too, so you can just use your line feature and kind of guesstimate what your angles are. If you have a pen tablet or something like that, you could use that. I don't really care how you turn it in, but you're going to need to either put it into a document, like a Word document or something like that, or use Paint and then save it as an image of some sort. If you have another program, you can use whatever you want, but you're not going to be able to fill out this PDF like we have been doing. So let's get back to this. It says go to the Bubbles Island, start at the Old Skull. So basically what's happening is that you're wandering around the Cartesian plane, and we're going to start right here. So this is, you are here. You're going to start here at the origin, and they give you direction angles and vectors. So they're going to say open up to this angle, turn and face this direction, and walk this far. And so we're looking at something like this aircraft example towards the end, where it says, turn to face this way, opening to this angle, and then go forward this far. And it's a little strange because we're using sort of the equivalent of what I called plane directions for car directions. And so what we're going to do is we're going to take our plane directions that use our angles, and we're going to convert it back to stuff that just says for, I's and J's, which is basically X's and Y's. You're going to get some weird looking numbers. We're going to round to the hundredths. If you already have gone through some of it and you rounded someplace else, you'll still get to the same spot. That's totally fine. The trick is to keep a running total. So when you're driving somewhere, every time you make a move, you don't go back home, right? You add that on, or you do that next turn from where you already are. So we're going to be looking at doing things like this. Well, I'm already went here, and now I need to go left, or I need to go right, or I need to go further a certain amount of space. So we're going to be adding vectors, sometimes subtracting if I have some negative numbers, depending on where I am on the plane. The first one's pretty easy, and it's almost a little deceiving. I wish we had kind of started out with one of the longer ones. It says go north 100 feet. And so that's pretty straightforward, right? So I'm just going to go north, due north 100 feet. And so I know I'm at the point 0, 100, which in vector form is just 100j. But all of the other ones are a little bit more involved. So let's think about, how would I describe this using direction angles? Well, I would have had to open up 90 degrees and then walk forward 100. So in using a direction angle, it would be a 100 for a magnitude. Go to the equivalent of cos 90 I hat, because that's the x part of my coordinate, and sine 90 j hat, because that's the y part of my coordinate. And then I can pull up my unit circle, use my calculator to say, well, cosine of a 90 is a 0. So that wipes out I hat. Sine of 90 is a 1. And when I distribute, well, that's how I wind up with 100 j hat. And so now I'm here. And the other directions that you're given will follow this way. So let's move my little dot of you are here, if I can. No, I guess not. Let's do it this way. Oop. So now we're here. We want to now do our next step, which says turn 40 degrees counterclockwise. So from here, which I'm facing, assume you're always facing the last way that you were walking, like, I don't know, shimmying left or right or anything like that. So I'm going to turn 40 degrees from where I was already facing, right? Because I'm facing this way. Yeah, I'll leave it like that. And then I'm going to walk 300 feet forward. So I'm going to go something like this. I'm just going to kind of estimate 300 feet. And so where is this is the question. What point do I land at? Well, I walked 300 feet. I didn't open up just 40 degrees. I opened up 40 degrees from where I already was, which was 90 degrees. So really this angle that I'm opening, if it would had been from here, is 130. And that's usually what kind of trips people up. So it's cosine 130, right? Because I already went 90. And now I'm doing another 40. So that's 130 I hat plus sine of 130 j hat. And these aren't going to be on the unit circle. So you're going to just have to use your calculator to do some estimation. Make sure it's in degrees. Let's make sure this is in degree. And the cosine of 130 is about that. So times 300 is about that. I'm going to say negative 192.84 I hat plus sine of 130 times 300, 229.81. But that is if I would have opened up from here. I didn't open up from there. I opened up from up here. So it's not like, let me see if I grab my yellow dot. I went like this. I got to scoot up to here. That's why I have to add it onto this 100J. So I was here, and now add on the negative 192.84 I hat plus 229.81 J hat. And you are at the point negative 192.84 I hat plus, well, 329.81 J hat. That's where my yellow dot is. Now I'm going to do another direction. All right, so I'm here, but you'll have to bring this over to get you started because you're not starting from 0, even though it's going to look like that from your position vector. You're starting from 192.84 I hat plus 329.81 J hat. And now you're going to do the next step and add that on to here. Now the next step says to turn, let's see if I can remember, 80 degrees clockwise. So you're facing this way, right, like this. And then you're going to pull, well, I guess like this. And you're going to pull this back 80 degrees. And then walk forward some amount. I don't remember, I think it was 300 again. Well, if I'm taking 80 degrees off of what I had already turned, right, so that's going to bring you back into the first quadrant. And you have a couple more steps after this, and you do something kind of weird like this. Kind of looks like a reverse question mark. And you're going to land about like here-ish for your treasure. And you're going to get, after you keep this running total of, I think, 2 more steps, you're going to say, all right, here's the point that my X was, that my treasure is at. But wow, it would have been a lot easier if you had just said do this. So once you get this, whatever this X plus I hat, X I hat plus J Y J hat is, you're going to say, well, why didn't you just say go this angle and forward this magnitude? And you could do this a couple of different ways. Pythagorean theorem is going to be the easiest. So I know it's going to look a little messy. Hopefully yours is not as messy as mine. But that's the kind of the steps that you have. And really, if you take this video, you only have 2 more. Now to walk due east, this is something that people tend to not really remember, is that means that's a 0. So due east is like this. So you got to turn whatever you need it to do to be 0. And here 0 is due east. And that should get you through the Chapter 9 lab.